We'll get started in just a minute. Okay, good morning, everyone. Hope you had a good weekend. Today, what we're going to do is we're going to go through the review and we're going to work the whole thing out together, okay? And that's all we're going to do today. And then we're going to, on Wednesday, we're going to have our finals. So when you come in here on Wednesday, you're going to need to have your camera set up the way that you have for previous tests, you know, everything the same. And then you'll submit your work to me when you're done, just like we did before. There's one thing here I've written down. You can have a single 8.5 by 11 sheet of paper, front and back. You can put anything you want on this except worked out problems. So what I don't want you to do is just take the review and just, you know, write down the review with all the worked out problems. That is not allowed. You can give yourself steps and hints like, oh, you know, for like, let's say graphing polynomials, right? When you go to graph these things, you're going to need to know all the steps, okay? So you can write those steps down, quadratic formula, anything that you think you're going to need, put it on your cheat sheet, reference sheet, okay? Are there any questions on that, on what's allowed, what's not allowed? You'll have to submit that with your work. Okay, so you will have to send that to me with your work, and if it has things on there that aren't okay, then you'll be points will be deducted. So just want to make sure everyone's clear on that. If you have questions, now's the time. No questions over anything else before we start the review?
I actually have a question.
Yes.
So as we've been doing the class, we've also been doing things like out of our workbook and like the reviews or anything. Are we ever gonna get a chance to like share those with you, or that's not something we're gonna share?
For, you mean like your homework and things that you've been assigned? Is that what you're talking about?
Yes.
So let me bring this up. We need to go back and double check our syllabus. I'm in the wrong semester. If I'm not mistaken, I believe there is a portion in the grade for homework, but let me just double check it. Yeah, so officially everything is exams. So that would only be considered as bonus. So what I would say is this, let's see where your grade lands after the final. And let's say you're like at an 88.4, okay? I think at that point, that would be somewhere where you could contact me, say, hey, you know, I have all my homework for the whole semester. And then maybe we can set up like a Zoom meeting and you can show that to me on camera. And then I could consider additional points. But that would maybe only impact your grade by maybe like 2 points total. So that would only be really helpful if like you were like at an 88 or something like that. And then you wanted to get it up to a 90. But otherwise I have to stick with what's on the syllabus. So it's just exam grades. Now we do have one exception. Exam 4 we didn't take, right? So with exam 4, I'm replacing that with your highest grade. So whatever your highest grade is out of all of these exams, whatever your highest one is, will take the place of that grade. Does that answer your question?
Yes, it does. Thank you.
Okay. Any other questions related to grades or the way things are going to work? So I'm going to probably post your grades by hopefully Wednesday night. And then I don't think they go official till Monday. So you'll have some time to contact me if you need to. So once you see the grades in Canvas for your final, at that point, from then till Monday, you need to let me know. After Monday, the grade will go official. So, excuse me. Anything else?
How much time do we have for the final?
I'm going to give you the whole class period. So from 11 to what, 1:40? Yep. Now we're about to do the review. And I think after I made the review, I looked at it and I was like, okay, this is probably about how long you should expect yours to be. I think it'll be this long. I may not give you 2 of each of these. I gave you really 2 of these sketching problems because I wanted to give you a little bit of variety. On the test, I may only give you like 1 polynomial and 1 rational function and 1 exponential. I don't know yet. Expect 2 of each, but I may reduce it a little bit just for time. We'll see. Let's work through the review and see how it goes, but I would not expect more than 20 problems. If anything, it'll be a little less. Okay, anything else? You all ready to get started on this? So everything what I'm going to do is I'm going to copy each problem down. And then we're just going to work through each one. And then I will post all of this on Canvas later on today. I'll send you all the work that I've done. All right. Okay, so here we go. First problem here is to perform the indicated operation. These problems were taken from your previous exams. A lot of them were. So I never provided you the answers to these. So let's work through this and make sure this is an opportunity for you to ask questions. I'm going to work through things and it'll be less like, it's not going to be me reteaching it. It's going to be me just going through it, assuming you know what to do. So it'll be very important for you to kind of like be like, hey, you know, I have a question, you know, how did you do that step? I'm going to leave that to you. All right. So don't be shy. Okay, here we go. So I need to perform the indicated operations. So I'm going to be using PEMDAS for this. And remembering that multiplication, division, and addition and subtraction go from left to right. They do not go multiplication before division, right? So I'm going to work inside the parentheses first. This parenthesis, I'm going to do what's in here first. So I need to take 5 and add -3. So when I take 5 and add -3, that's going to give me 2. And then minus, now I need to do what's in this parenthesis. And so I have these bars around -2. That's the absolute value of -2. The absolute value of -2 is +2. And then -6. And I still need to square that. So now I need to figure out what 2 minus 6 is. If you take 2 and subtract 6, you get -4. So this becomes -4 squared. And now I'm going to do the exponents here. That's the next thing on my list. So I'm going to do this squared. So I have to square -4, and that means -4 times -4. Negatives, when they multiply, become positive. So this should become positive 16. And so now my next line looks like this: 4 times 2 minus, and then this became 16. Now I do -4 times 2, that's -8, and subtract 16. And if you take -8 and subtract 16, you should get -24. Any questions there? Okay, next one. Now I'm doing this, working this out today. I mean, I'm assuming this is kind of what you want me to do, is to just work through this. You know, if you're one of those people like, I want to work through it all myself, you don't necessarily have to watch me do this whole review. But usually when I ask the class, like, what do y'all want me to do? Most of the time students just want me to work through this. So just letting you know, if you want to do it yourself, go ahead, that's fine. Okay, so for this one, we want to solve for x. And then we want to simplify our answer. So when we look at this right here is an equation, and it's linear because there's an x to the first. So we have a linear equation. And to solve this, we have to follow a set of steps. If you don't remember, you'll have to go back and look at your notes. The steps are like clear all fractions or remove decimals. Simplify each side, so distribute through parentheses. Collect all your x's on one side, all your numbers on the other side. Okay, so go back and look at that. I'm gonna just work through it. Okay, here we go. So first thing I'm gonna do is I'm going to distribute a -2 through the parentheses. So that's gonna give me 3x minus 2x plus 10. Negative times a positive is negative, and then negative times a negative is positive. That's why I have those. And 7x plus 20. Okay, on the left side, I can collect 3x and 2x together. So those are like terms. So I subtract, I just get 1x. And now at this point, I've done everything I can on each side. So I'm going to move all my x's to one side and all my numbers to the other. So since I have a 7x on the right and a 1x on the left, I'm going to subtract x on both sides. That leaves me with a 10 equals 6x plus 20. And then I'm going to get the 20 out of the right side. So I'm going to subtract 20 on both sides. That gives me -10 equals 6x. And now because I have 6 times x equals -10, I will divide both sides by 6. So I get -10 over 6 equals x, because the 6's cancel. And that fraction reduces because 2 goes into both of those. So I get -5 over 3 is x. Questions? All right, next. Factoring the GCF. Let's see. Maybe we'll squeeze this in here. Let's see. Maybe. I'll put it right here. Okay, so factoring the GCF. So when we talk about GCF, that's greatest common factor. I have 2 terms because there's subtraction here between the 2. And so I'm going to look first at numbers. What number goes into both of these, right? So 2 goes into 2 and 2 goes into 6. So I'm going to have 2 out here. And now I'm going to look at the letters. I have an x and an x squared. So they both have at least one x in them. So that's part of my common factor. Now I look at the y's. This one has a y squared. This one has a y cubed. So they both have at least 2 y's. So I'm going to put y squared here. That's my GCF. Now what's in here, I need to leave enough space for 2 terms because I started with 2 terms. And I just need to figure out what do I multiply this by to get this back? And then what do I multiply this by to get this back? So can someone tell me what goes here on these two? Like what would I have to multiply this by to get this?
1.
1. So don't forget that you have to have a 1 there. That's a common mistake. Students are like, oh, well, I already have that. You have to have a 1 here so that when you distribute, you get this. Then comes a minus sign. And then now I need to turn the 2 into a 6, so I'll need a 3. The x has to become an x squared, so I need an x. And the y squared has to become a y cubed, so I also need a y. There it is. All right, moving along. Number 4. So simplify is the instruction here. Simplify, what that means is we're going to multiply this out. So this is a problem where you have to understand how to expand polynomials. So what I said in class is that you start with the first term x and you distribute that through to the 3 terms. Once you do that, then you move to the second term, which is a -2, and you distribute that through. So you're going to have a total of 6 multiplications to do here. So this should be equal to, let's do the first one. X times 2x squared gives me 2x cubed. X times positive 3x gives me positive 3x squared. And then x times -4 gives me -4x. So that's the first multiplication of the blue little curves here. Now I do all the green ones. So -2 times positive 2x squared gives me a -4x squared. And then -2 times positive 3x gives me a -6x. And then a -2 times a -4 gives me a +8. And this is not completely done yet. We need to simplify this, so we need to collect like terms together. I have only one x cubed term, okay, so I'm going to have 2x cubed. In terms of x squareds, I have a +3 and a -4x squared. So putting those two together, I should just get -x squared. Or -1. You can put a 1 in front, you don't have to have it. And then as far as x's, I've got this one and that one. Those two together become -10x. And then the 8 here is by itself, so that'll be +8. Here you go. So just be careful with your signs. Be careful collecting like terms. All right, here we go. If it took Trey 2.15 hours to bike 34 miles, then how long will it take him to bike 10 miles? So the first thing we do is we set up a ratio proportion from this information. We have that in 2.15 hours, Trey can bike 34 miles. Or you could look at it the other way around. And Trey can go 34 miles in 2.15 hours. So you get to choose here which one of these you're going to use. Now the question is, how long will it take him to go 10 miles? So how long is going to be the x for us? And the 10 miles is going to be the other part of the fraction that we know. So we always put the x on top, x hours over his miles, 10 miles. And we want to solve for x. So we're going to set this equal to one of these two proportions. And the one that we're going to use is the one that has the same corresponding ratio, which is hours over miles. So I'm going to use the 2.15 hours over 34 miles. So I'm not using that one because it has the miles on top and I want hours on top. And then at this point, there's two ways to do this. I think I remember doing this. I swear it was Bonnie that asked this. I can't recall exactly, but I think someone had asked, can we just like cross multiply? And I said, yes, but you don't have to. You could just multiply both sides by 10 right now, but I'm going to do the cross multiply because that's what most people are going to do. So I multiply 34 times X, it gives me 34X. And then I multiply the 10 times 2.15, I get 21.5. And then to solve for X, I divide both sides by 34. So X is equal to 21. So this is where you need your calculator. 21.5 divided by 34. I get 0.632. I'm just going to go 2 decimal places, 0.63 hours. Remember, we were saying how long does it take them? Questions there? Okay, so for this one, this has to do with tax on a phone. And there's a sale price. So I'm going to let you start this. I'm just going to go refill my drink, see if you can get some of this on your own. I'll be right back. Okay, sorry about that. So the phone costs us $880, or that's the cost of the phone. But it's on sale today for 8% off. So I need to figure out how to take 8% off of this price. And there were two ways to do that. You could either figure out what 8% of this is and subtract it, or the way I said is more efficient is to figure out if it's 8% off, then that's really 92% of the original cost. So the way I showed y'all how to do this, which you don't have to, but this is, I think, easier, is to take the 880 and multiply it by 0.92. 0.92 represents the 92% that you have to pay, right? 8% off is the same as paying 92%. So I'm going to just get on my calculator and take 880, multiply it times 0.92, and that gives me a new price. So this is how much the phone's going to cost, $809.60. So that's the sale price. That's what I'm going to pay tax on. So now I'm going to use a formula that looks like this. The total is the price plus the price times the tax rate R, where R is the tax as a decimal. Which means the total we're going to pay is going to be the 809.60, that's the sale price, plus that 809.60 times the tax rate, which is 8.125% converted to a decimal. So I need to move that decimal point 2 places to the left. So it becomes 0.08125. So I'll do this on my calculator. I'm getting 800, when I put everything together, 875.38. This is dollars. Okay, questions there? This might be something you want to put on your formula sheet, right? Right, next thing we want to do is sketch a line. So when we were talking about lines and sketching them, there were two methods that we discussed. There was the intercept method, and then there was the slope intercept method. So I think what I'll do is I'll do this both ways, okay? Because you on the test can do either way. So let's do the intercept method first. If you do the intercept method, what you're going to do is find the X and Y intercepts. So to find the X-intercept, I'm going to set Y equal to 0 and solve for X. So if I take that equation, I replace the Y with 0, I get -2 over 3x plus 4 equals 0. And now I have to solve this for X. So I subtract 4 on both sides. And now this is the part that sucks. I've got to get rid of this -2/3 that's in front of the X. So what I would have to do now is divide both sides by -2/3. When I divide the left side by -2/3, sorry, the right side by -2/3, it goes away. That's why we do it. And then I have X equals, now this is the part I think can be tricky. -4 divided by -2/3. You have to look at that as being -4 divided by -2/3. And that's the same as -4 over 1 divided by -2/3. And remember that division can be converted to multiplication by doing keep dot flip. See if that rings a bell. Keep dot flip. And now multiplication goes straight across. So you just multiply straight across. So you should get -12 over -2, which is +6. So your answer here should be 6. Now we need the Y-intercept. I'll do that right here. The Y-intercept, to do that, you set X to 0. So if I rewrite this equation and I replace the X with 0, everything here goes away because 0 times -2/3 is 0. So all I get is the 4. And that was much easier to do. So now we can sketch this. We have an X-intercept of 6. So I go out to 6 and I put a dot here. I have a Y-intercept of 4. So I go up 4 and I put a dot there. And then I connect those two with a straight line. Any questions on that method? Now the slope intercept method, which I think is much easier for this problem, is to use the fact that if your line looks like y equals mx plus b, then it's easy to sketch it. And our line actually does look like that, right? Our line looks like y equals m, so this would be our m times x, and then plus this right here would be our b. And what we learned is that when we have this form, all we have to do is start with the y-intercept of 4. So we've got 1, 2, 3, 4. At 4 here, we put a dot. And then to get to another point, we use the slope. And this right here would be our rise. And this number here would be our run. So to rise by -2 actually means I go down 2, and then a +3 means to the right 3. So I'm going to go down 2 and to the right 3 from this point. Down 2 to the right, 1, 2, 3, and I put a point here and draw a line connecting them. So either way, I don't care which way you do it. Any questions there? Okay, the next problem, this one I think is better if you do it the X-intercept way, because see, it's not solved for y. So it's easier to do it using the, the X-intercept way, the intercept method. So let's find the X-intercept. To do that, we set y to 0. So if I set y equal to 0 here, this is what I'm going to get. -2/7 x equals 1. And then at this point, I need to get x by itself. So I divide both sides by -2/7. 1/-2/7. This leaves me with an x here. And then be careful on this one. This is 1 divided by -2/7 is the same as 1 times 7/-2. So keep dot flip again. And this 1 times anything is itself. So we should just get -7/2. And it doesn't matter if that negative is on the top or the bottom. I'm just going to put it out here in front. And on a calculator, that's -3.5. It'll be easier to graph if we have it as a decimal. Now to get the y-intercept, I'm going to set x to 0. And if I do that, I get 1/14 y equals 1. And I think the easiest way to solve this for y is just multiply both sides by 14. So if I multiply left by 14 and the right by 14, the 14s here cancel, you're left with y equals 14. So now you can sketch. The x-intercept is -3.5. 1, 2, 3, 4. That's -4. -3.5 is right about here. And then y is 14. We go up 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14. And we draw a line connecting those two. Oh, there we go. I'm not going to do the other method on this one because it's much harder. So I'm just going to leave this work. Again, the big difference between these two, this one is already solved for y. So it's perfectly suited for this method. But if it's not solved for y like this, then the intercept method is usually easier. Any questions there? Number 9. Where's number 9? A lot of y'all got this problem right on the test. Okay. So my electric bill charges $12 a month for service and $0.04 for every kilowatt used. Find a linear model which gives the monthly cost as a function of the kilowatts used. We're going to let X be the number of kilowatts used. So my cost will be equal to, what we have to do is in this problem, recognize what's the fixed cost. That's fixed. I pay $12 a month no matter what, no matter how much electricity I used. That's our fixed cost. And this is our variable cost. This is the amount that I pay, and it depends on how much electricity I use. So you'll always take the variable cost, put it in front of X, and add to that your fixed cost. And that will be your linear equation. Cost is 4 cents for every kilowatt used plus $12. Okay, part B says, how much will it cost if we use 720 kilowatts in a month? So that means I'm going to replace the X with 720 and figure out how much that'll be. So I just get my calculator out, do 0.04 times 720, add to that 12, and I get $40.80. Now, it says if my bill is $320 in a month, how many kilowatts did I use? This time we use this formula, but we replace the cost with 320, and we set it equal to 0.04x plus 12 and solve for X. So there's a big difference between part B and C. Here we're replacing X with the 720. Here we're replacing the C with the 720. I mean, sorry, with the 320. So I subtract 12 on both sides. If I subtract 12, I get 308 equals 0.04x. And then I will divide both sides by 0.04. That's a lot of kilowatts. 7,700 equals X. That's how many kilowatt hours we used. All right, y'all doing okay? Is this helpful at all? I feel like hopefully it is. No questions? All right, sketching time. All right, so you need to know the steps, okay? And one of the things that I need to warn you about on this test is that when I ask you to sketch something, I'm not going to tell you what type of function it is. So you're going to need to be able to look at it and know what steps to use, because remember, the steps to graph a quadratic are different than the steps to graph a polynomial, and those are different than the steps to graph a rational function, and those are different than the steps to graph an exponential function. So you need to know by looking at it what you're working with here. So the fact that this is x squared tells you it's a parabola. This is a quadratic. Okay, this is a quadratic. So you want to follow the steps for a quadratic. And let's see if we can find the steps. I'm going to try and do this quickly. Let's see. Yeah, here we go. So yeah, this should be it. This is sketching. So where were our steps? I think they're going to be on the previous day. There we go. Here we go. Dang it. I know it's here somewhere. I'll just show you an example. We figure out if it opens up or down. We find the vertex, which is a formula. We do a quick sketch. We find the X-intercepts if we have them. We find the Y-intercept, and then we draw the picture. Okay, so go back in your notes, find those steps, put those on your formula sheet. Okay, so here we go. What am I doing? Okay, so first thing, I look at this thing, first step, it opens down. The reason I know it opens down is because A is -2. Oh, you know what? Let's write down what A, B, and C are. A is -2. B is the number in front of X, which is +8. And C is the number by itself, which is 7. Okay, so A was negative, which meant that this thing opens down. Second step, vertex. To find the vertex, I need to figure out what H is. H is always the -b divided by the 2a. So for me, -b is -8 over 2 times the a, which is -2. So this is -8 over -4, which gives me +2. So H is +2. To get K, what we do is we take that 2 and we plug it into the function. So -2, then we're going to do 2 squared plus 8 times 2 plus 7. Order of operations, 2 squared is 4. Multiply that times -2, you get -8. Plus 8 times 2 is 16, plus 7. This is going to be 8 plus 7, 15. So your vertex is the point 2, 15. Third step, quick sketch. So I'm going to do a real quick sketch of this. 2, 15 means I go to the right and up. So to the right and up, I have a vertex here, and it opens down, which means I know that's my highest point. And that means I'm going to have 2 X-intercepts. And that means I need to do step 4. So step 4 is the X-intercepts. Anyone remember how we do X-intercepts? How do you do the X-intercepts? Take the function and set it equal to 0 and solve this. So at this point, you can either try and factor, which I don't think it's going to factor. So you'll have to use a quadratic formula. That's x is -b plus or minus square root b squared minus 4ac all over 2a. Okay. So I am going to do this. I'm not going to show the work for this, if that's okay with everyone, just for the sake of time. I'm going to, well, you know what? I'll do it. I want to see how long it takes me to get through this test. So let me go ahead and do it. This will be x is equal to, see, -b will be -8 plus or minus the square root of the b, but squared. So take the 8 and square it, 64, minus 4 times a, which is -2, times c, which is 7, all over 2 times a, which is -2. This gives me -8 plus or minus the square root of 64. Now, because I see 2 negatives, not 3, I see an even number of negatives. I know I'm going to have a plus here. And now I just need to multiply 4 times 2 times 7. So 4 times 2 is 8, 8 times 7. Let's 8 times 7. 56. Over -4. This equals -8 plus or minus, you know, I'll move down. I think I'm out of room here. Let me do this, move this up. Okay. So this will be -8 plus or minus the square root of 120, I believe. all over -4. So this is -8 plus or minus. I do the square root of 120 on my calculator. Gives me about 10.95 all over -4. And now at this point, I do two different cases. I do the plus and I do the minus. So this part I'm just going to do on my calculator. -8 plus 10.95, then divide that by -4. You should get -0.74, and then -8 minus 10.95. Divide that by -4, I get 4.74. Those are my two X-intercepts. All right, so now step 5. I need the Y-intercept. For the Y-intercept, I just plug 0 into the function and I get 7. All right, now we're ready to put it all together here. All right, so go to draw my graph. Let me change this to graph paper. All right, so my vertex was at 215, right? So I'm going to go out to the right 2, up 15. Do I really want to go up 15? 1, 2. I'll count by 2s. 2, 4, 6, 8, 10. There's 10, 12, 14, 16. There's 16. So 215 will be right here. That's 215. And then my X-intercepts were at 4.74. So if that's 2, this is 3, that's 4, that's 5, there's 5. So 4.74 will be a little bit before it. 4.74. And then if this is -1, -0.74 will be about right here, -0.74. And then my Y-intercept was 7. So 2, 4, 6, 7 is here. And now I just draw my parabola. Remember, you have this axis of symmetry. And so it should look like a mirror image of itself over that. So nice and curved, come down through here. That. Make sure it's not a V. There we go. Okay, good. Questions? I'll leave that up. Let's take a 5-minute break. I'm going to come back and continue on. Let me see. I think what I'm going to do is I'm going to leave this one to you. All right. And then we'll pick up in 5 minutes. We'll pick up on number 12. All right. I'll go back and put that back up here. Take a quick 5-minute break. Okay, everyone, it's been about 5 minutes. I'm going to go ahead and pick up where I left off. Again, I'm skipping that one problem, leaving that to you. Same method as you did in 10. But I'm going to move on to the next word problem with the rock. So a rock is, it says here, a rock is thrown upward with a velocity of 32 feet per second from a 50-foot bridge. So as far as cheat sheet or reference sheet, you're going to need to know the formula for this. And the formula was d of t equals -16 t squared plus v naught or v sub 0 t plus d naught. Please make sure you have that on your reference sheet. Now, for the problem, this 32 feet per second will represent your velocity, and you'll know that because it'll say like feet per second. And then this right here, 50 feet, will be this d naught, which is your starting height. So that means you can rewrite this as d of t equals -16 t squared plus 32t plus 50. So now we have the specific quadratic equation for this particular rock. And now we go, that's part A. Now we do answer parts B, C, and D. So when they're asking for the maximum height and when it reaches its maximum height, they're actually looking for the K and the H from the vertex. And then when they want to know how long it takes to hit the ground, we're asking for the X-intercepts. So we're going to, all you need for this problem is the vertex and X-intercepts. Once you have that, you're done. So to get the vertex, I first calculate H, which will be -b over 2a. That's that same formula again that you'll need. So for us, B is 32, so -32 over 2 times A is -16. So you happen to get -32 over -32, which is 1. And then to get K, we plug 1 into this function. So we get -16 times 1 squared plus 32 times 1 plus 50. So you should get -16 plus 32 plus 50, which should give you 66. So we can answer part B and C right now. Part B, what's the maximum height? This will be 66 feet. And the time it takes to reach is 1 second. So this is the K, this is the H. Now, how long does it take to hit the ground? For that, I'm going to just use a quadratic formula. So I'm going to take this and my solutions will be -b plus or minus, I'm using quadratic formula, square root of 32 squared. So you'll probably need your calculator for this. 32 squared is 1024 minus 4 times A, which is -16, times C, which is 50, all over 2 times -16. All right, so I'm going to do this -32 plus or minus square root. Okay, when I do that, 4 times 16 times 50. Add that to 1024. So you should get 4224 underneath the square root there, or -32 equals, got to take square root of that. So -32 plus or minus about 64.99. all over -32. Be careful here. Don't cancel these -32s. That you're not allowed to do that. You have to do the plus or minus first. So now I'm going to get my 2 cases here, my plus and my minus case. So -32 plus 64.99, divide that by -32. I should get -1.03. And then when I do the minus, I get 3.03. So this is how long it takes for it to hit the ground. I'm going to throw away the negative answer because it doesn't make sense. So it's 3.03. And that'll be my answer to the last part, 3.03 seconds. Okay. All right, now we get to the sketching. All right, so let me do one of these. I'll let y'all pick. I'm going to either do 13 or 14. I'll let y'all pick if anyone's still there paying attention right now. 13 or 14. What do you want?
Let's do 14.
Okay, I'll do 14 and I'll leave 13 to you. All right, so here we go. I'm gonna try and squeeze it in right here. So now what we're doing is we are sketching a polynomial function. So the reason we know this is a polynomial function is because the powers here are bigger than 2. So this is a polynomial function, and there were a set of steps for this, okay? The first step was to find the left and right behavior using that table. Remember that table? Where, it said like, up, up, down, down, all that. You need that table on your reference sheet. Make sure you have it. So for this, the degree of this is 5, and the leading coefficient is the 1 in front. So we have an odd degree and we have a positive leading coefficient, which tells us that the left side will go down and the right side will go up. And in the middle, we don't know. I'm not going to have enough room. So let me grab this. Okay, now the next step is the X-intercepts, and then we also have to figure out whether or not we bounce or cross. So I'm going to take the original function, and I'm going to set it equal to 0. And you should always start here with a GCF, so I can pull out an x cubed. I'm left with x squared minus 8x plus 16. And now I want to try and factor this. So I take the number in the back, 16, and the number in front of the x, which is -8, and I come up with 2 numbers that multiply to be 16 and add up to be -8. And my 2 numbers are -4, -4. So that means this turns into x cubed times x minus 4 times x minus 4 again. That's very important because watch my next line. It's going to be x cubed times x minus 4 squared, because there's 2 of them being multiplied. And that's critically important because of the next step. You set this equal to 0. You set that equal to 0. This answer, the only number you can cube and get 0 is 0 itself. Here you get x is 4. But now we have to determine if we cross or bounce. So we go to the powers here to figure that out. So because this first one is odd, we will cross. But because this one is even, right, 2 is even, we are going to bounce. Picture time. Start with the X-intercepts, which are at 0 and 4. I know that my left side has to go down and my right side has to go up. I know that when I draw this, when I get to 0, right, that's 0. When I get there, I'm going to need to cross through. And then when I get to 4, I need to bounce. So I'm going to go up, cross through, come back down, bounce, and go back up and connect that. So that's what I'm looking for there. Okay. That's it for that one. So I'm leaving you with number 13. All right, same thing. What do y'all want me to do? 15 or 16?
Let's do 16.
16? Okay. So I'm going to leave you with 15. Let's take number 16. Okay, so for number 16, this is a rational function. We know it's a rational function really because it's a fraction. That's kind of should tell you. But we have to do all the steps for this. And if you go back and look in your notes, it's a bunch of steps and they suck. Okay, so first thing I'm going to do is find the X-intercepts. And to do that, we set the top equal to 0. Now be real careful here on this step. There's a couple of ways to do this. I'm going to do it this way. I'm going to add 32 to both sides. I'm going to divide both sides by 2. That gives me x squared is 16. And then I'm going to do the square root on both sides. And when you do the square root on both sides, you have to do plus or minus. Do not forget that plus or minus. So you get 2 answers, plus or minus 4. That's one way to do it. Another way you could have done this is to factor Gcf out. So factor 2 out. And what is that? Oh, sorry, I wrote the problem down wrong, 32 here. When you factor out a 2, you get 16, x squared minus 16. And now you can look at this as being a difference of squares, x plus 4, x minus 4. And now you set each of these equal to 0. 2 equals 0, x plus 4 equals 0, and x minus 4 equals 0. The first one, 2 is never equal to 0, so you don't worry about that. These two give you the answers -4 and +4, which are the same 2 answers you get here. So in this, you have choices. You can do it this way or this way. So we have 2 X-intercepts. Remember, those are going to be points on our graph. The next thing is to find the vertical asymptotes. And to do that, you set the denominator equal to 0. This one works a little different because they both have an x. So I can factor an x out and be left with x minus 9. And then set each of those equal to 0. So I get x is 0, and then this one gives you x is 9. These are vertical asymptotes. These are dotted lines. They're barriers. They force our graphs up or down. Third step is the horizontal asymptote, and this was the tricky one. What you're going to do is you're going to look at the degree of the numerator and denominator and compare them. And we had different cases. So let me remind you of the cases. Let's see. Here were the cases we had. And I told you that the only thing I was going to ask you was, let me move this over and then we'll talk about it. So I said that the only thing I'm going to test you on is the part A and C, that we're not going to do part B. Okay, so the question is, when you look at these degrees, 2 and 2, are they different or are they the same? So in this case, they're the same. And then in that case, you have the leading coefficient of the numerator divided by the leading coefficient of the denominator. So this is the special case. You have to look at the leading coefficient of the numerator, 2, and divide that by the leading coefficient of the denominator, which is 1, and that's 2. So we will have a horizontal dotted line that's moved up 2, but it's only at the edges. So let's draw our picture. So we have okay, let me get our X-intercepts first. These are part of our graph, the X-intercepts, 4 and -4. I should have used a different graph. There we go. 4, so 1, 2, 3, 4. Here at 4, we have an X-intercept. At -4, we have another X-intercept. Those are points on our graph. Then from step 2, we have 2 vertical asymptotes at 0 and at 9. These are vertical dotted lines. 6, 7, 8, here's 9. So I'm going to draw a vertical dotted line here, vertical dotted line there, and then I have to do one at 0 also. And this is where I told you it's hard to draw dotted line on top of the y-axis, so just make little dashes. So these are vertical barriers. And then, very important, we have our horizontal asymptote, which is up 2. So we go up, here's 2. And I told y'all to only draw the dotted lines out to the edges. So here and here. So don't go all the way across, just at this edge, left and right edge. Now we need test points. So I'm going to pick a test point over here, -5. Test point here, -1. Test point here, I'll just pick 2. A test point here, I'll pick 6. The test point here, I'll pick 11. So I have 5 test points. And the reason I have 5 is because I had 2 X-intercepts and 2 verticals. So that was 4. I should always have 1 more test point than those 2 added up. And these numbers, unfortunately, get plugged into the original function. So I'm gonna copy this original function here. I'm gonna bring it down here so I can use it. And all we care about is whether or not it's positive or negative. So if I take -5 and plug in, what happens? If I take -1 and plug in, what happens? If I plug in 2, what happens? If I plug in 6, what happens? And if I plug in 11, what happens, right? That's what we want to know. Okay, so if I plug in -5, I'm going to do 2 times -5 squared minus 32 over -5 squared minus 9 times -5. All right, this is kind of tedious, but let's see, -5 squared is 25. 25 times 2 is 50. So we get 50 minus 32. And on the bottom, 25 squared, -5 squared is 25, and then negative times negative here would be positive 45. And I can see right away that this is a positive number on top and a positive on the bottom. So positive and positive together gives me positive. You have to do that for each of these points. I'm not going to do that. I'm not going to go through this work. I'm just going to tell you what they are. Then you'll get negative, then positive, then negative, then positive again. So the work here is not shown by me, all right, but you will have to do that on the test. So what do we do with this? At -5, that means I'm going to put a dot somewhere above, so I'm just going to put it here. At -1, I need to put a dot below. At 2, a dot above. At 6, a dot below. And at 11, a dot above. And now we connect these together. I'll start at the leftmost point. As I draw to the left, I have to go towards the magnet that pulls it. Then I connect, and then my vertical forces me down here. Then I move to the next point. As I draw to the left, the vertical forces me up. Then I connect, and then when I go to the right here, the vertical forces me down. Then I go to my next point, to the left, the vertical forces me up. And then to the right, it goes towards the magnet. And that's what we're looking for there. Let me leave that up for a minute for people to copy down. I'll zoom out just a tad so you can see it if you need it there. Okay, so I'm leaving you number 15 as a practice. 17 and 18, I can do these pretty quickly, so I'll just do them both. Okay, so if to sketch these, the way I said, these are exponential functions. The reason you know they're exponential is because your x is up in the exponent. So to do number 17, what I'm going to do and what I expect you to do on the test is simply make a t-table. Put x here, put 1.75 to the x here, and then we're all going to use the same numbers. We're all going to plug in -3, -2, -1, 0, 1, and 2, and 3. So those 7 numbers, you plug those in, 1.75 to the -3, 1.75 to the -2, 1.75 to the -1, 1.75 to the 0, 1.75 to the 1, 1.75 to the 2, and 1.75 to the 3. And you're going to use your calculator for these. So let's see here. 1.75 raised to the x. Okay, so if you do to the -3, you get 0.187 and around here. If you do -2, you get 0.327. If you do -1, you get 0.571. If you do 0, you get 1. If you do 1, you get 1.75. If you do 2, you get 3.06. And if you do 3, you get 5.36. Now, I didn't mention this, but because 1.75 is bigger than 1, this should be exponential growth. So when we graph this, we should expect it to look like this. Let me do that though. 1, 2, 3, -1, -2, -3. Okay, let's plot these points. So at -3, I'm really small. I'm at 0.187, so really small. -2, I'm a little bit bigger. At 0, I'm 1. Okay, so I should have put that there. At -1, I'm at 0.57, so something like that. At 1, I'm at 1.75. At 2, I'm past 3. So 1, 2, here's 3. So a little bit past 3. And then at 3, I'm up past 5. So 4, 5, somewhere around here. And then just connect these together with a nice curve like this. And just remember over here, this flattens out towards a magnet. And that's what I'm looking for. Are there any questions on that? That's all I want. Okay, for the next one, for this one, let me just show you what the table would be. So here's x, here's 0.75 to the x, -3, -2, -1, 0, 1, 2, 3. I'm just going to give you the answers here. So -3, it's 2.37, then 1.78, then 1.33, then 1, then 0.75, then 0.56, and then 0.42. And if you graph these, then let's see, this is 1, here's 2. So at -3, you're at 2 point something. Then at -2, you're at 1.7. At -1, you're at 1.3. Then you're at 1. Then you're at 0.75. Then 0.56, 0.42. So it's an exponential decay. So you have that this side goes up, it's going up, and then flattening out over here to a horizontal. So what I'm most concerned with is that your picture looks like the correct type of growth or decay. Like you need to make sure you have that right and this right. And then of course your table values need to be correct. Okay. We're almost done. All right, so I'm going to do one of these. Let's do number 20, and I'll leave 19 to you because they're basically the same problems. Okay, so for this one, we are doing a simple interest problem. All right, simple interest, which means you're going to need this formula. A equals P times E raised to the R times T. Make sure you have that formula on your reference sheet. So we owe $12,000 on a credit card. The interest rate is 15.5%. How much would you owe after 6 years if you didn't make any payments? So that don't bother with penalties. I'm sure you get plenty of penalties and fees if you didn't pay for 6 years, but we're just going to say if the interest just kept accumulating, then we need to be able to recognize what these values are. This right here is our P, that's the principal, it's how much we're starting with. This right here is our interest rate, has to be converted to a decimal, 0.155. Then it can be plugged in for R. And then the 6 years is going to be our T. So the amount that we would have, that we would owe would be 12,000 E raised to the 0.155 times 6. So 12,000 E to the, I'm going to do that on my calculator, 0.155 times 6, so 0.93. And now on my calculator, I'm going to do E raised to the 0.93. So you need to make sure on the test you know how to use your E key. And oh, I should say this, no phones on the test, okay? It's only calculators. 2.53 and multiply that 2.53 times the 12,000. And you will owe $30,360. So at a 15.5% interest rate, $12,000 is going to turn into a $30,000 debt if you don't touch it for 6 years. Okay, everyone. It's what, 12:30? So that took me, I think we took about 15 minutes at the beginning of class. So that took me about an hour and 15, hour and 10 minutes, something like that. So I'm guessing it'll take you at least twice as long, maybe longer. But we'll have 11, 12, wait, we start at 11, 12, 1. You'll almost have 3 hours. It'll be closer to like 2.5. So we'll see how it goes. Just be prepared for these types of problems. Are there any questions?
Will you send us the answers for the ones we left out when you send us the review?
For 11, 13, and 15, and 19, you want the answers for those? Is that what you're saying? Yeah,
Yes.
I can send those. Yeah. Okay. Well, I don't really have anything else for you today. So what I'll do is, if you're happy, you're free to go. If you want, you can hang out. And what I'm going to do is I'll work through the 13, 15, 19, and 11, 13, 15. I'll work through those right now. But what I'm going to do is I'm going to just work them. I'm not going to like talk to you. I'm just going to work them out. And you can kind of watch and follow if you'd like. You can always interrupt me and say, hey, what did you do there? But I'm not going to talk through it. And you're welcome to stay or leave. And then after I'm done with those, I will come back and I'll say I'm closing the session out. Sound good? Darshil, do you have a question?
Yeah, I was going to ask you if you can scroll back down to the resolution for number 20.
This one? Any other questions? Okay, I'm going to work through those problems in just a moment. Thank you all for your participation and attendance this semester. I know it's been hard with Zoom to do this and do it in the summer. We definitely did not get through all the material we're supposed to, but I told you on the beginning of class, like, you know, there's 2 college algebras, right? And y'all are in the one where most of you don't need any more math. So really, this should not have like an impact on you as you move on. I will say that, you know, if you're getting into one thing we didn't get into that might come up is conversions. Like, you know, convert 23 milliliters to liters or something like that. And the thing is, like in the real world, we often use technology for that. Like even doctors, if they have to convert medical, like medical dosages and stuff, they usually just use an app on their phone because the app's not going to make a mistake as far as the math. So in the real world, I think conversions are left to technology. So the fact that we didn't get to do it by hand here, I'm not real concerned about. That said, you know, if you're a nursing major or something like that, you might have to do some conversions by hand later, but they'll be very similar to what we did with like the tray riding the bike problem, where you set up a fraction, another fraction, and, you know, cross multiply, things like that. So that's just summer, 8 weeks, hard to get through everything. So that's where we are. Anything else? I'm going to start working these problems out. Darshil, are you okay with this? Thumbs up, you're right? Okay. All right. Here we go.
Professor, I have a question.
Yes,
In the test, should we round our answers to 2 decimal places or 1?
I will probably say on there 2. But as long as you're doing everything right, if you round 1, it's okay. It won't be counted wrong.
Okay, and the reference sheet we can use like back and front, right?
Yes, both sides.
Okay, that's it. Thank you.
Yep. Okay, everyone, I finished this, so I'm gonna save this and email it to everybody right now. Is there anything else anyone has question-wise? Okay. All right, well, in that case, I'm going to email this out. Everyone have a great day, and I will see you on Wednesday.
Thank you. You
Okay,
too.
thank
You have a good day.
You too.